Alright, how's it going, everybody? We are up to video 4. This is our last talk about the unit circle. So the videos 1, 2, 3, and 4 together should make you prepared and ready to go. Should know what you're doing with this once this is all said and done. Now, the only thing that this video is going to concentrate on, you can see this board is blank and ready for me to talk about a couple of small things, and then this is still the same old unit circle. Everything's gone. All that's left is the dots. We are strictly talking radian measurement here. That's it. What are the radian equivalents to 0, 30, 60, 90, 45 degrees, all that stuff? That's what we're working on. So, the whole premise of my video is going to be based off of this one fact. 180 degrees 180 degrees is equivalent to pi on the radian scale. So you can say that a few different ways. You can say half a circle, 180 degrees, pi radians. They're all the same thing, okay? So I'm going to add that to the circle over here. Pi radians. So I'm going to do this in pieces. The way that I do radians, and eventually I end up mostly memorizing them because I just say them so often, but I know a counting system. Fractions of pi. So right now what I want you to look at, again, half the circle right here, that's pi radians, 180 degrees. I want you to look at the black and the blue dots only starting from the beginning of the circle. Now before I do that, let's please note that's 0 radians as well. I mean, if the angle hasn't started rotating yet, it's 0. So that's the nice thing about radians and degrees. They both start from a 0 measurement and move forward. If we look at the black and the blue dots only, we talked about this, or I talked about this in the previous 2 videos. The black and the blue dots are evenly spaced. In the previous videos, I said they're 30 degrees apart. But I'm talking about radians this time, so I'm just going to say they're evenly spaced. So if I start here, I just want to count a minute to see how many even spaces it is to get to that pi. So starting right here, this is my starting point, 0 radians. It is 1, 2, 3, 4, 5, 6. So it's 6 even spaces to get to pi. Then it would be fair to say this is 1/6 of the way to pi. That's 2/6 of the way, 3/6, 4/6, 5/6, 6/6. 6 over 6 being 1 pi. So what you often would see me, if I was in the classroom, what I would be doing is counting that out right here and saying 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. And I would tell you guys, those are notes to myself. Normally I say them in my own head, but I want you to see them this time. So those are notes to self. That's 1/6 of pi, 2/6 of pi, 3/6 of pi, 4/6, 5/6, 6/6. 1. 6 over 6, 1 pi. Keep counting though. Skip the red dots. So if I keep going, this is 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. Let's talk about that one a minute, because this one we probably should have had that one on the paper already, or on the board. We all know that 12 over 6 is 2. 12 divided by 6 is 2. That's 2 pi. I think it should be a little bit obvious. If halfway around the circle is 1 pi, completing that circle is 2 pi. 1 pi, 2 pi. Now, it's time to actually start putting the real radian measurements, because again, those little fractions that I wrote, they're just notes to me. They are not answers yet. So I'm going to do two things right now. I'm going to say the fraction, reduce it if it needs to be, and then write the measurement. So 1/6 doesn't reduce. That's 1 pi over 6. 1/6 of a pi. We're going to keep the pi in the numerator. So these are answers now. Pi over 6 radians. 2/6 reduces to 1/3. 1 pi over 3. 3/6 reduces to 1/2. 1 pi over 2. 4/6 reduces to 2/3. 2 pi over 3. 5 over 6 doesn't reduce, so we call it 5 pi over 6. We're already here to 6 over 6. That's 1. 1 pi. 7/6 doesn't reduce, so that's 7 pi over 6. 8 over 6, that reduces to 4 over 3. So this one is 4 pi over 3. Kind of cramped for space down here, so I'll make it work. 9/6, that reduces to 3/2. 3 pi over 2. 10 over 6 reduces to 5/3. 5 pi over 3. 11/6 doesn't reduce. 11 pi over 6. And we already did 12/6, which is 2 pi. Now, you guys, we talked about this in actual class. If you were to take the time to take every degree measurement, convert it to radians by the pi over 180 conversion factor that we talked about before our extended break here, you get all these numbers. But there's a way to count it. We might as well count it, and you can get pretty good at this in your head. Be like, 1, 6, 2, 6, 3, 4, 5, 6. You don't even have to say the sixth. They're sixth. So it's 1, 2, 3, 4, 5. Oh, 5 pi over 6. 6, 7, 8, 9, 10, 10, 6, 5/3. 5 pi over 3. You learn to do that stuff in your head quickly. So that's your challenge. Next. And we're kind of almost done here because the big stuff's been done now. We have to include the red dots. In the previous videos, I call them the 45 dots because they're the halfway point of each quadrant, which is 45 degrees into each quadrant. Now again, we're talking radians now, so we want to stop saying 45 stuff. This time, I'm going to count again, different count. I'm going to start at the beginning, which is the black dot. I'm going to only hit black and red. Skip all blue. The blacks and the red dots are evenly spaced too, but they're a different spacing. So if I do what I did before, come over here, start at the beginning, and only go red, black, red, black. 1, 2, 3, 4. See, this pi is everything. So it's the basis of my counting. It's 4 jumps to get to pi. That means that's 1/4 to pi. That's 2/4 to pi. 3/4 to pi. 4/4. So if I write those notes to self, and I'll write those in red just like the other dots are in red. Now I know I'm gonna be hitting these black dots again. I'm still gonna label them. There's a point to be made there. So we'll start here. That's 1/4, 2/4, 3/4, 4/4. Keep going. 5/4, 6/4, 7/4, and back to the beginning, 8/4. Because there only takes 4 to get to there, and therefore we're on a 4th count. So we're going to do the same thing in that we're going to reduce where we need to, and then actually write fractions of pi in the answer spots on the outside of the circle. Now, you're going to notice something I'm going to tell you right now. All the actual red dots, none of their fractions reduce. But please remember I had to label the black dots again. They're a part of the rotation, so I want you to see that. But anyway, this is 1/4 of pi. So that's 1 pi over 4. But just notice that this, for the fourth count, was 2/4. For the sixth count was 3/6. I don't care what you're looking at. 2/4, 3/6. That's 1/2, people. So that's why that's still 1 pi over 2. This is 3/4. Doesn't reduce. 3 pi over 4 radians. 4/4 is 1, just like 6/6 was 1. Down here, 5/4. That's 5 pi over 4. Down here, this is a relabel, but again, I want to show you that 6/4 and 9/6, they both reduce to 3/2, 3 pi over 2. And last one that is new, 7/4 is 7 pi over 4. And then the 8/4 was already part of the 12/6. Again, 8 over 4, 12 over 6, they're both 2 pi. So folks, there's the radian amount. Holy cow, that sun came shining in there, didn't it? Hopefully it didn't blind out. See, think the circle's in line, but it blinded that board right out. So that's all right. So you guys, you see the radians in the circle. So in closing, because this is the end of the 4 videos here, you should now, with practice, be able to fill in the unit circle completely. If I sent you in a link, I'm now going to send you links to these videos. Obviously, you're going to be seeing the video before you hear this announcement, but along with, there'll be a worksheet, let's say, that you have to fill in the circle on your own. And you should be able to. You should be able to put in all coordinates, with square root of 3 over 2, 1/2 as a big part, square root of 2 over 2 is a big part. Obviously, there's 1, 0, 0, 1, -1, 0, you know, those. And you should be able to put in all degree measurements. I showed you how to count that out earlier. And now you should be able to learn and practice the count for radians. You know, the 1/6, 2/6, 3/6, and the 1/4, 2/4, 3/4, and so on. So, that's that. That's the end of this segment, and we're going to be moving on to something else when the next set of videos start. All right? Thanks for tuning in, people.